The next application of loops that I want to look at is how can we use a loop to average a series of numbers. First of all, to create an average, we're going to need to add up multiple numbers. And if we're using user input to get the numbers, we can add the numbers as we go. As we get each number, we can add them to what's called a running total. And that's just when we're adding one at a time in a loop. At any given time, that running total is going to show us the current sum. And it's kind of like when you're at the grocery store and you look at the checkout screen, and it shows you what your current total is for the groceries that have been rung up so far. Sometimes we'll call the variable that's storing the running total or the sum an accumulator variable. It's just accumulating a total of numbers as you go. And then finally, a lot of times when we are adding numbers, we'll use a counter variable. And the counter variable lets us keep a count of how many numbers have been entered so far. Depending on how we've written our program, we may not know how many numbers are going to be entered until all of them have been entered. So to create an average, I'm first going to have to add up all my numbers, and that's going to be in my accumulator variable. Then I'm going to divide that sum by my counter, or the quantity of numbers. So let's first look at how we can get the total. So a lot of times when we have a fixed number of items, we'll use a named constant for the number of values. In this case, I have a named constant called QTY for quantity. And by convention, we'll often use all capital letters for our named constants. They stand out in our code. We know they're not a variable that we can modify. Now to create my running total, I need an accumulator variable. Here I'm using a variable named sum. And then each number that I'm wanting to add, I will store in the integer variable number. In this case, because I know how many numbers I want to enter, I'm going to use a for loop. And in this for loop, I am going to define and initialize my counter variable I with the value of 0. In programming and other things with computers, we often begin counting with 0, and that's what I'll do in this case. And because I'm counting with 0, I'm going to execute this loop as long as my iterator variable or counter I is less than QTY. So my test condition is I less than QTY. And then every time this loop iterates, I want to increment I by 1. So I can just use I++. I'll then prompt the user to enter a number inside the for loop. I'll get the number from the user, store it in variable number, and then I'm going to add that number to my running total in my accumulator variable sum. I could have said sum equals sum plus number. Instead, I've just used the combined operator here, sum plus equal number. So the first time in the loop, sum was already 0. If I were to enter the number 5, now sum would have a value of 5. And I go back up to the top of the loop and ask for another number. Once I've gone through that loop 5 times and entered all 5 numbers, the test condition will no longer be true. I'll exit the loop, and now I can display the sum. So let's first build that in our program, and then we'll come back and add the code that we need to do the average calculation. All right, so just like I showed you a moment ago, I have a named constant quantity, QTY. It's initialized with a value of 5. And because it's a named constant, once it's been initialized, we can't modify its value. And then I have an integer variable number. and another one called sum. And sum has already been initialized with a value of 0. So let's build a code where we can get the 5 numbers and create the running total. So this is for averaging numbers. And I'm going to scroll this up just a little bit. Now I'm not going to be able to see my variable names and once I start writing more code, but I know what they are. I'll just go ahead and let them scroll off the screen a little bit there. And let's build a code to first get the numbers entered. So again, I'm going to use a for loop. For loops are great when we know exactly how many times we want the loop to execute, which I do. I want 5 executions or iterations rather. So I'm going to say for int I equals 0, define an integer variable named I and initialize it with a value of 0. Execute the for loop as long as I is less than qty. And then every time the loop is executed, go ahead and update i's value by incrementing it by 1. And this is a very standard for loop. For loops are often written where we will define and initialize an iterator variable, such as I, in the header of the for loop. We will often say int I equals 0. And then we'll compare I to the number of iterations by using the less than sign. We will not use less than or equal, because if we did that, we would actually execute this loop 6 times because we're starting with 0. And then finally, we'll often write a for loop with an I++ in it. Now, I could have written it as a prefix operator of ++i, and that would do exactly the same thing in this situation. Some people prefer I++, some prefer ++i, but either way, we're going to get the same result in our for loop. All right, so I'm going to prompt the user now to enter the number. And so after the prompt, then I will use cin to get the number, and I'll store it in variable number. And once I have the number, I now need to add it to my running total. I'm going to say sum plus equal number. And that's my running total. So once this loop has iterated twice, I'll know the total of 2 numbers. Then after the 3rd iteration, I'll know the total of the 3 numbers. And so at any given moment, I'll know the current total. But the way this loop is written, I will no longer know the value of each individual number. I'll only know the value of the last number entered, as well as the sum. So let's go ahead and add up those 5 numbers, and just so I know what happened, I will then echo that sum back on the screen. Something simple like sum colon. And that should do what we need so that we can test this program. All right. I still have the code here where we were doing the input validation a moment ago. I'll enter a valid number to get past this. And now I can see the code here where I want to enter the number. So I'm going to enter, say, number 7, then on number 23, and I'm just making up numbers here off the top of my head. And how about, 197, just to round it out. There are my 5 numbers. And once I press enter on 197, then I'll see the sum of the 5 numbers. So the first time in the for loop, I had a value of 0 when I got the number 7. It had a value of 1 for the number 23, 2 for 89, 3 for 2. I had a value of 4 with 197. And what's going to happen as soon as I press enter over here, Can't quite see it with all of that. Let's move this over here. We add 197 to the sum. I had a value of 4. I will get incremented to a value of 5. 5 is not less than 5. The for loop will end, and then we'll see the sum echoed on the screen. So I'll press 197 now. And that's what we see, that the total of these numbers is 318. So now that we've totaled the numbers, the next step is to calculate the actual average. So we use the loop to add the numbers. Now that we have added them, after the loop ends, now we'll divide the sum by the quantity of numbers, or the count. One thing that we do need to watch out for, however, is integer division. Whenever we're working with integers, I do want to use an integer variable as my accumulator variable. And I'm going to be dividing that integer sum by the quantity, which will also be an integer. And integers divided by integers have their decimal values truncated. Now you might think, well, let's just fix that problem by using a double as our sum, and that would work pretty okay. However, when we're working with doubles, we are no longer doing integer addition, and we're doing real number addition, and that's going to work a little bit different with doubles. So we're going to have some imprecision with that. It's better to stick with integer variables for the sum if we're working with integer variables. And so instead, what I'm going to need to do is I'm going to need to cast one of my numbers, for example, the sum, as a double before I execute the division. So if you can't remember what that looks like, you can see that here in this example, where again, those are the variables I've been working with, except I've added variable average. There's the for loop where we got the numbers and we got the running total. What I'm going to add at the end now is the average calculation. I'm going to put static cast double around the variable sum before I divide it by quantity. And static cast uses the data type between the angled brackets to temporarily change sum's data type from an integer to a double, so that we're dividing a double by an integer. We'll perform floating point division, and we won't lose the decimal places with the division. So now let's go ahead and add that additional logic to compute the average to our program. So I'm back in our program. We already created the running total. Now let's add the logic to compute the average. So I'm going to add a calculation right after the for statement ends, or the for loop ends. And I'm going to say that average equals static I want it to temporarily become a double, and the variable that I want to statically cast is variable sum, and then I'm going to divide it by quantity. Now that I've computed the average, the only thing that's left is for me to echo that value back on the screen. It's going to look a lot like the sum did, except I'm going to say average. And use the variable average and another line break. So let's go ahead and test this program. We still have our input validation, that's fine. And now I'll enter my 5 numbers. Why not add a big number there at the end? All right, and I have a sum of 715. It gives me an average of 143. So it turns out the 5 numbers that I entered happened to come out to be a multiple of 5. So when I divided by 5, It didn't really matter whether I had done a static cast to prevent the integer division. The best thing to do now is probably to test it one more time with a value that will not be a multiple of 5. So I'm going to close this window and try again. Since I'm randomly choosing numbers, I guess there's a 1 in 5 chance that I happen to choose 5 numbers that are a multiple of 5. And I did not intend to run this in a debug mode, so that's why my debug library is having to load. I'm going to go ahead, and I don't want to do debug right now. I'm going to close that window out, and we'll try that again to run it outside of the debugger. All right, let's try that again. Debug, start without debugging. It doesn't have to load the debug library, so the program loads right away. And I'm going to now enter a 7, which is a number between 1 and 10. And now I'm going to enter 5, 5, 5, 5, and 2. I know that will not be a multiple of 5. I press enter, and now I'm going to see that the sum was 22. The average is 4.4. That looks correct. And so it appears that I'm correctly computing the average of those 5 numbers.